Hello. In this video, we're going to talk about how to solve quadratic equations. So let me put those two words together. Equation, meaning you have an equal sign, a left side equaling a right side, and you have to figure out what values of the variable, what they could be in order to make it true. Now, a quadratic equation involves a quadratic expression in it. So you can see that up here. This is a quadratic equation. It's quadratic because the degree is 2. And it's a polynomial, ax squared plus bx plus c, where a, b, and c are numbers. So that's why it is quadratic. Solving linear equations is much easier. Like if I just had 3x plus 2 equals 10, I can solve that pretty quickly. But with quadratic equations, we need different methods. So this is a quadratic equation. Not an expression because we have it equal to a number. So here's an example. And in this course, we've actually solved problems like this before using factoring. We talked about how you set it equal to 0 and factor. So I just want to remind you of that, what that looked like in the past. So this is a trinomial with a equaling 1. So a is 1, b is -6, and c is -7. So a, b, and c are constants. They're numbers. You don't include the x when you identify what a, b, and c are. So if you remember, with factoring, I wanted two numbers that multiply to -7, but add to -6. So that's going to be -7 and +1. The product is -7, you multiply that, and the sum is -6 when you add it. So because a is 1, I can go right to the factorization. I don't have to do it the long way. So that's going to be x minus 7, x plus 1, equaling 0. So from here, to figure out what x could be, we took each factor separately and set it equal to 0. So whatever makes x minus 7 equals 0, whatever makes x plus 1 equals 0, those are going to be my answers. 7 and -1. And we were able to solve this quadratic equation by factoring. So factoring is going to be one method to solve a quadratic equation, like figure out what makes this equal 0. But now we're going to practice another way, and it's called the quadratic formula. And I'm going to do the same problem with a different method. Quadratic formula. So mathematicians, they solved a quadratic equation in general for x. And what's true every time is that x is equal to this formula. So in the quadratic equation, we have values a, b, and c, those coefficients. And they found that the answers are always in the form of the opposite of whatever b is. So if b is positive, it's now negative. If it's negative, it's positive. So that's why we say the opposite of b. It's not like it's always negative, whatever. Plus or minus. So we're going to get two answers, which makes sense. I got two answers here. Plus or minus the square root of b squared minus 4 times a times c. So 4ac, that all needs to be multiplied first before you subtract it from whatever b squared is. And then that's all over 2 times whatever a is. That formula gives you the answers to a quadratic equation equal to 0 every time. Isn't that nice? You don't have to remember all the different ways to factor a quadratic formula. It's pretty cool. And all you need to do is plug in A, B, and C. So let's redo this problem. So it says x squared minus 6x minus 7 equals 0. And I already know the answer should be 7 and -1, but I want to show you how this formula works. So a good way to start is identifying A, B, and C. A is 1, B is -6, and C is -7. So wherever A is, that's going to be plugged in to A. B is going to be plugged in for B. Oh, you know what? I shouldn't put in the negative. So B is here, and B is here. And then C is -7. That's going to go right there. So here we go. X equals -b, so -6 plus or minus the square root b squared -6 squared. So b squared should always be positive, minus 4ac. Now I'm putting that in parentheses because I don't want to write like 1 times -7 without parentheses. It might look like 1 minus 7. All over 2 times a. Now this is why we practice simplifying expressions like this. So what I get is 6 plus or minus the square root of 36, -6 squared, that's always going to be positive, minus 4 times 1 times -7. So minus a -28, so it's going to be plus 28 all over 2. 50, 64 all over 2. So this is why we have to practice this here. So I have to simplify this. I have 6 plus or minus root 64 over 2. And I want to simplify the root first. So that's just 8. So we have a perfect square there. It's not always going to be a perfect square. Sometimes it might even be negative and you end up with imaginary numbers in your answer. And I get 14. Oh, wait, okay. So I have to split this up into the plus version and the minus version. So I'm going to get whatever 6 plus 8 over 2 is. And I'm going to get whatever 6 minus 8 over 2 is. All right. 6 plus 8. Let me just erase this. 14 over 2 is 7. 6 minus 8 is -2 over 2 is -1. Look at that. I got my answers of 7 and -1 using the quadratic formula. And you might look at this one and be like, oh, well, I know how to factor. And factoring is much quicker. It was much cleaner, like this old way than this new way. But the thing is, not every quadratic equation factors. Like, what if I can't find 2 numbers that multiply to this and add to that? So you can't solve every quadratic equation by factoring, but you can solve every quadratic equation with the quadratic formula. And that's why the quadratic formula is so great. Works 100% of the time, every time, as long as you simplify correctly. Now, sometimes you'll be able to add these 2 things together, like the 6 and the root 64, and get just like 2 answers that are integers. But other times, it might be like 6 plus or minus root 20, and like you can't simplify root 20 into an integer. Like it's 2 root 5. And you just have to simplify that as best you can. So sometimes you can add them together like we did here, and sometimes you'll leave your answer as what's called irrational. So this is kind of our intro video, and then there will be a follow-up video with more examples.